my company, has a partnership with Cincom. And as part of that partnership, sometimes they get consulting requests. And they sometimes hand those off to me, and I'll go and work on those projects. This particular one was from an organization that was saying, you know, we do a lot of prototype user interfaces, and it's just a lot of work for our people to create those user interfaces and lay them out. So is there anything you can do to make it easier to lay out user interfaces? So we proposed this to them. Fluid positioning. Well, let's start off with VisualWorks just by itself. In pure VisualWorks, when you try to lay out a user interface, you're presented with this, the UI Painter tool. How many people use the UI Painter tool? Fairly common. You drop controls onto the paint canvas, and then after you put them on, you normally have to fiddle with the positioning of them so that when the window gets larger, the widgets get larger appropriately. In some cases, widgets don't get larger, like maybe buttons or labels, so those are fixed size. The variable size ones you want to get larger as the window gets larger. And to do that, you have 8 positioning parameters that you normally play with. Therefore, the left, top, right, and bottom edges. And for each one of those, you have a fraction and an offset. So the idea is to calculate where this thing is, where this border is. You take the width of the window, if you're positioning left and right, multiply by the fraction, and add the offset. For top and bottom, you take the height of the window times the fraction plus the offset, and that tells you what pixel that edge is going to be at. And the problem is that those fractions and offsets can be rather hard to calculate, especially if you want to have a nice looking layout. So here's a layout where we have a tab control. Above the tab control, I want a 2 pixel gap before the top of the window. So my fraction is 0 for the top of the tab control, and my offset is 2. But down at the bottom, let's go to those buttons at the bottom, the OK cancel buttons, you want to be relative to the bottom of the window. So you want their fractions to be 1. So the offsets have to be negative to go up from the bottom. -2 for the bottom of the button, -25 for the top. Based on that, I want a 2 pixel gap between the top of the button and the bottom of the other controls. So I have to calculate a 1 and -27 for the bottom of the controls. And all the other ones, I have to start calculating what fraction I want to get the right layout. And it's rather time consuming. So this is part of the problem of how to lay out the user interface in VisualWorks. So my goal with fluid positioning was to try to make this layout more automatic. I didn't want to fiddle with the positioning parameters. I wanted to just drop something on and have the system say, hey, that's a text input box, that's variable size width and variable size height, and I will take up all the available space. But when I drop something on top of it, it says, oh, wait a sec, now I have to share the space with this new thing that you're dropping on top. For fixed size widgets, let's say a label or an input button, when you put it onto the screen, there's extra space to the side of the button. And then you can choose whether you want it to snap to the middle of the screen, or maybe to the left side, or maybe to the right side. So I'm trying to make this as automatic as possible. And ideally, if you use fluid positioning, you shouldn't have to fiddle with those layout parameters. If you do a little bit of research, you'll find that there are some layout algorithms out there. One common one is called Awkward. When I saw this, I thought, wow, that's really cool. They use constraints. So basically, they would have inequalities that they would specify for all of the edges of all of the controls. So for instance, I want the right side of this control to be greater than the left side of that control. Or I want the right side of my control to be greater than the left side of my control. And you come up with a whole series of inequalities. And in addition, you put in what they call an optimizing function, which is a function that computes a value, and you want to try to minimize that value or maximize the value. To solve this, there's a standard technique called the syntax method, which is used. This is called linear programming. And it solves this. It comes up with a nice layout that uses up all the space and lays things out very nicely. The problem with the Auckland layout algorithm is that it's not really suitable for VisualWorks. There are two problems with it. First, there's no obvious way to hook it into a UI Painter tool. All of the constraints in Auckland are specified by programs. So you and your program have to say, this widget is to the right of that widget, and you don't get to see it until you run the layout, and it draws the screen for you. So that was one problem. A second problem is that the layout has to be calculated at runtime, so that Auckland algorithm runs every time you resize the window. It will recalculate the positions of all of the widgets on the window. And it doesn't translate nicely to the VisualWorks technique of having fractions and offsets. So I wanted something that would calculate the fractions and offsets for you, but not necessarily completely take control of the positioning of these widgets. So I figured that the Auckland algorithm wasn't really appropriate for our use. This algorithm is now in its second iteration. The first iteration was a trial to see how this worked. And I thought it would work really well this way, and I was wrong. So I will show you how it works the original way, and I'll show you why I was wrong. And I'll show you what I'm aiming towards. So this is a work in progress. And I think one of the lessons of this is algorithm development is really not that easy to do. And I have some other lessons I've learned that I'll describe at the end of the talk as well. In algorithm 1, you observe that widgets are normally laid out in groups. So here's your UI. I have one group of widgets that's laid out horizontally. The first input field up, if I can get this. I'm not going to bother. The two input fields on the top and the button, that's a horizontal layout. The two buttons at the bottom are another horizontal layout. And we wrap all of those into a vertical layout that lays out the horizontal, the middle input field, and the buttons at the bottom. So you can see from the GUI Painter tool, you can see a hierarchy of the GUI. And those composites are what I call oriented composites. So they know whether they're laying out in a horizontal direction or a vertical direction. They're basically a subclass of groups or composites. So I figured this was the natural way to lay out a UI, because you always have things that are grouped horizontally or vertically. And it's natural to come up with that kind of a hierarchy. And since you're laying it out automatically, the users don't have to worry about fiddling with the hierarchy. They just drag the controls around. Which brings up an interesting question. If I'm going to do this layout, how do I actually calculate it? If I have 3 variable width controls, and let's say 3 buttons laid out like this, how do you calculate the fractions and offsets going all the way across? And it took me a little while to figure out exactly how this does work. It turns out that the fractions are easy. If I have 3 variable size controls, and I'm going to assume for the moment that you want these all to be the same width, okay? We'll talk about changing the width, the relative width afterwards. But suppose I want them all to be the same width. Then my fractions are going to be thirds, because I have 3 variable width controls. And I'm going to lay out the first 2 controls to go from 0 to 1/3, 1/3 to 2/3. The buttons are all laid out at 2/3. The left, right of each button. In the middle, they're all 2/3. The left side of the last input box is 2/3. Then the right side and everything for the last button are 1. So the fractions are easy. You just divide by the number of variable size controls. The offsets aren't quite so easy. To calculate the offsets, you want to know how much space is fixed that you really can't control. You can't make it bigger or smaller. So I take all of the margin sizes, 2 plus 2 plus 2 plus 2 plus 2, all the 2's for margins between the widgets. Plus, each of these widgets is 54 pixels wide, and I add those up, and I get 176. So the idea is going to be, I'm going to take that 176 and in an evenly distributed way, steal space away from each of the variable controls to make up 176 pixels. So that when I lay it out again, I can use up that space for the margins of the buttons. To do that, you keep a running offset as you lay it out left to right. For fixed size controls, you simply add the fixed width to the offset, and that applies to margins as well. For the variable width controls, you subtract off the fixed width, the total fixed width, divided by the number of variable widgets. So in our case, that would be 176 divided by 3. I'm not going to go into the details of this calculation, but in a nutshell, you start at 0. Every time you pass a margin, you add 2 in. Every time you pass a variable size control, you subtract 58.67, which is 176 over 3. Every time you pass a button, you add 54. And if you collect all of the results of all those calculations, you get all of the offsets going left to right, and it works out. You do have to keep some sort of floating point or fractional value for the results, because if you keep truncating down to an integer, you're going to lose a pixel here and a pixel there. So as you calculate each one, when you set the layout into the actual widget, you'll certainly round it. But that intermediate result, you'll use as a pure floating point result as an input to the next iteration. Let me first start by showing you how that works. Now, let me first say that to get this to work, in the settings panel, there is a setting under UI Painter for the algorithm you wish to use to I guess manage the button, manage the mouse for the layout. And the ones that were there were released and held down. So either you moved your mouse around and when you were finished you clicked, or you click first, move it around, and when you're finished, let go. Those are the 2 algorithms. I added in fluid released and fluid held down. So you're going to see fluid released here. So here we go. Start off with a text editor. I'll drag that into the canvas, and it colors the text editor this bluish color, so you can see that this is the control that you're dragging around. If I don't do that, then it's really hard to see which control you're dragging, because they kind of all look the same. This one takes up the full size of the window, because there's nothing else on the window. So it's taking up the full size for us. Suppose I want to drag another one down. I pull it down. Now it does a layout, seeing that I'm closer to the top than to any other edge. So I'm going to lay out this control on top of the other. So the new control is going to go on top. There's a 50% fraction for each of the top and bottom of the widgets with a margin in between. And it does that automatically. I haven't dropped my control yet, so I can move to the right. And now I'm closer to the right edge than to the top edge. And it says, oh no, I want to rearrange that and push this new control to the right. And now it's 50-50 divided down that way. Let's keep that. Let me take another text control, or text editor. Right now I'm right in the middle between the other two text editors. So it says, yeah, you want to put your text editor here, in between those other two. I could have chosen to put it over there, or over there, or at the top, or down at the bottom. So it bases it on where's the closest edge to the mouse. And that's the direction that I'll put the control in. Here's another control. Again, I can drop it between these. I can drop it to the top, to the left of those. There's a special case that as I move close to the edge, it'll say, I'm going to just drop this completely outside. Of course, that doesn't read there. Outside of the controls. And now I have this whole thing and all the rest to the right. So again, I can drop that down wherever I wish. This is the kind of feeling I wanted to get from the layout, where it does things automatically. It says these controls are naturally laid out in this way. I just need some hints from you on where you want to place it and how you want to put it down. I got this working. I had it working horizontally first, then a combination of horizontally and vertically, and it works great until you start adding in fixed size controls. To a certain extent, it works fine. Here's a button. I'm going to put the button to the top of the screen. With fixed size controls, you have extra space, in this case, to the left and to the right. And so it says, well, since you're closest to the center, I'm going to center the button. So if you look at the properties of this button right now, it'll say that the left and right are relative to 0.5, and then there's a left offset and a right offset to make the right size of the button. As I drag the button over this way, it snaps to various useful fractions. This is 1/3. This is, this is 0 here, 1/4, 1/3, 1/2, 2/3, 3/4, and then right justified. So anytime you go to drop a button down, it'll look at its enclosing box and choose which of those tab stops you're closest to and snap to that one. So if I want to put this button in between these two fields, these two text boxes, I could center it in between like that, or go up to the various other fractions. So there's my button. So far, this is much easier than trying to lay it out by hand and set up all those positioning parameters. And just to prove that this works, I'm going to take this window, make it bigger and make it smaller, and you can see that the positioning is all correct. Next, I'm going to take another button and put it down. You're going to start to see the instability of this algorithm. And this is why I've abandoned this algorithm and I'm working on a second version. But I'll try and demo it as best I can. Here's my second button. See, there's a bit of instability there. It pushes those other things down. That's fine. I can snap properly here. You can see the flashing. And that's part of the problem with this algorithm. I can put these buttons side by side or one on top of the other. The problem that I'm running into with this is that, first of all, there's ambiguity we have to deal with. And there's ambiguity in any case. Let continue on here. When you put a widget down, what do you mean? If I have my window here, and you can see a little circle that I've drawn. My mouse pointer is right there. What does that mean? Which of these pictures do you want? So I resolve it based on how close I am to the edge and which edge I'm closest to. The problem that I have is that when I'm moving widgets around, those things that I'm dragging around are inside composite objects which have their own little coordinate system. And those composites are inside other composites which are inside other composites. And when I move things, I may have to remove it from one composite and put it into another, and then recalculate all of the fractions and such. And that makes it tricky. I actually had to sit down with a sheet of paper and do some high school algebra to figure out how to recalculate the fractions and offsets when you change frames from one composite to another. That was fun. There's also a little bit of a bug in VisualWorks that ungroup doesn't actually get it right. Not that people really use group and ungroup in this context very much, I think. And you can't really resize widgets that are inside a group. So those are things that were causing a bit of trouble. Another problem was that I'm trying to edit the layout parameters in the window itself, in the layout with wrappers themselves. And that means that I kind of have to have the window correct to model what you're seeing on the screen, but I can't sort of do experimental things. I can't say, gee, would it work if I did this? If I tried it, the screen would flash, or things would reposition, and I'd get all messed up. And sometimes if I move my mouse into one spot, the algorithm would say, you're going to put this under that, and when it puts it under, it repositions things, and in the next frame it says, oh, you want to put it over this other thing, and then flips it back. So the algorithm was flipping back and forth between configurations. This layout is being done on every mouse move. So if you move the mouse a little bit, sometimes it would flash back and forth. So those are the instabilities that I ran into. We delivered sort of an early draft of this to the client and said, we're not really happy with the stability of it, but it does what you ask for, but you really have to be kind of careful with it. And then we came back later and said, do we have permission to try again and come up with a better technique to do this? And they said, sure, go ahead. So we started with algorithm 2. With algorithm 2, we now look at the user interface as being totally flat. I'm not going to have hierarchies anymore. They were just too hard to deal with. So no more oriented composites. And the one big factor is now I'm using an actual explicit model of the layout. So I have my own model of containers and boxes and tab stops that models what I want to happen on the real user interface. And I can fiddle with this all I want, and it's not going to flash, it's not going to recalculate. I can take a snapshot of this and store it so that later I can restore back to this. It just gives me a lot more power. The other thing I'm trying to do is orient things around what I call tab stops. A tab stop is actually the space between edges of the controls. So if I have two buttons side by side, they are sharing the tab stop in the middle. And what I really want to do is to lay out the tab stops, and based on where those tab stops are, calculate where the buttons are. And that's pretty easy when you know where the tab stops are. When you start doing this, you start to find that it's really much easier if you move your mouse onto the window to have your mouse be over something already. If you can find a box that you're currently over, then you can find out what the tab stops are, and you can find out which edge you're closest to and do all sorts of calculations. Otherwise, you have special cases. You have special cases of If I'm over a widget, then I do this. If I'm not, then I do that. If I'm over a widget, or if I'm over something which was a composite in the old algorithm, then I do things one way, otherwise I do things another. And it was very messy. So with this new algorithm, I'm trying to have empty areas in places where there's empty space. And since I have an external model, I can model those empty areas and not have it reflect itself onto the user interface. The layout is now based on paths. Left to right paths and top to bottom paths. So basically, in the first diagram, I start at the left-hand edge and say, well, there's really only one control here. So I have one starting point. But then that control, I'm sorry, there are two controls here. Let me go down and point these out. The first control is this one here. That's represented by this line. But I also have an empty space down here. Now I'm showing the empty space in this diagram for demonstration purposes. But in reality, you're not going to see that empty space on the user interface. But I have two paths, one that starts here and one that starts by going down here. So from this tab stop to that tab stop, to that tab stop, to that one, to this is one path through my system. And another path is I can go from here to there, then I could go in one of two directions, and finally meet up at the last tab stop. So my paths are the connections from tab stop to tab stop. That gives me a graph, and now on that graph I can traverse it and ask how long are each of these paths. I'll take the shortest path, lay that out, and then as I go through this graph again and again, I can find, well, I've already determined where one tab stop is. I know where the previous tab stop is. That means I know where this one is. And eventually calculate all the tab stops. And I have the same thing going up and down on the vertical side. So I'll do a horizontal layout first, and then a vertical layout, and then my whole UI is laid out. That's just what I described. Let me show you that new algorithm actually, and then I'll get back to the left to do. Here's another image that was in the oven ready to go. There's my first control. And just like before, I can take a second control, drop it down, put it to the right, put it underneath, to the left, and I can drop it somewhere. Now over here, you'll notice that there's no hierarchy. These are just two controls that are on the user interface side by side and not inside any groups. I can take another control, put it at the top, put it between the other two, down at the bottom. I can push it underneath one or underneath another. And I'm going to leave it right down here. What I find with this algorithm is that I actually have more options for doing layouts than I had before. So for example, right now, if I drop another control in, I can put it above this one, to the left of this one, to the right, above this, below that. I'll put it to the far right. I can lay it out like this, or down at the bottom. So I have much more control. I'm starting to get now the mix of variable and fixed working. So I'm going to bring in a button. I can push it right to the top above everything. Put it between controls, and again it snaps. I'm trying to keep it with just a 50%. I'm taking out the 1/3, 1/4, 2/3, because I don't think they're really all that useful. So I'm just going right now with a 50% snap. Here I am between these controls, between those ones on this edge, that edge, and it's fairly intuitive the way it works. Much of that flashing and flickering that was going on before is gone here. So this algorithm seems to be more stable. I'll drop that right down at the bottom. What I'm finding now, and this is work that still needs to be done, I'm having some fun trying to manage these empty spaces. Right now with that button at the bottom, there's an empty box to the left and an empty box to the right. But when I drag another control onto it, now I have two empty boxes to the left and two empty boxes to the right. Should it make them one empty box or not? Interesting question. And as I bring it down further, I start getting weird things like this going on. And that's because it's miscalculating the heights of those boxes, those empty boxes that are taking up the extra space. So there's where my current bug is in the algorithm, is getting these weird sizes. So this is the good, the bad, and the ugly. At this point, that layout isn't quite working. But let me show this. I'll take a label, drop it on. I can drop the label at the very top of the whole window, above this control, like that, to the left of the control, underneath the control. So I can do reasonable layout on that label. So that's basically where we are right now. I'm still working on the algorithm. I have to finish adding in the fixed size widgets. I have to have an ability to install and close the painter and then reopen it. That did work with algorithm 1. I could save everything in the window spec and then reopen the window later and have it all come back, and you can still do fluid positioning. With this version, there's a whole window model that is modeling the tab stops. And I have to decide whether I want to save that model as part of the window spec or try to reverse engineer it from the window spec when I bring it back in. So that I have to do. I'm building algorithm 2 on top of algorithm 1, which means I have a lot of code for the old algorithm that's really obsolete and I have to take out. So that cleanup is still remaining. So a few lessons that I've learned from this. One of them, I mean, I knew this anyway, but developing an algorithm is hard. And sometimes when you think that this certain approach will work great, you try it out and in practice it just doesn't work. So you have to back up, reevaluate what works and what doesn't and why, and then try again. Incremental development in this case was rather limiting. I could do horizontal development great. Even with mixed and variable size controls, horizontal development was not bad. When I mixed horizontal and vertical, that's when I started to have problems. When you mix horizontal and vertical and variable and fixed size elements, that gets really complicated. So I had an algorithm that worked for part of it, and when I tried adding to it, I found it added more and more complications into the mix. I do have, let me see if I can show you this, a testing framework to allow me to write tests for these. And these have turned out to be rather instrumental in being able to get this to work. So let me just run these tests. I'll start by showing you one of the tests to see what it looks like. Basically, this test says, it's probably not very readable. Let me see if I can do something to, not easily. This is not a Mac, I can't just make it bigger. This says select palette placement class text editor spec. So I'm saying use the text editor, press the button at this XY coordinate. The window that it opens for the UI Painter it's automatically opened by the test case, and it will be 640 by 480. So that's my size of the window. And so I say press the button at 630 by 10, release the button, press it at this other spot, release the button, and then check that the layout looks like this. And this is an abbreviation of what your layout should look like. So it's just a static array. So if I go to step into this, I'll do it slowly. choose text editor, press the button here, release the button, press the button over there, release the button, and then check that the layout is like this. And that should pass. So all of these test cases should pass. Actually, let me run all of them. That was actually essential for getting rid of the whack-a-mole problem. In general, with this sort of layout, it's really hard to fix one thing without breaking another. So having a test suite that I could run to make sure that everything that used to work still does work, that's essential. And even though it was a bit harder to write the infrastructure for this framework, because it drove user interfaces in more complicated ways than just find a field and type something into it, it was worth the effort, because now I can check that I didn't break anything. And the last thing is that even if I have a fairly complete test suite, I can't depend on the test suite alone to verify that the functionality is correct. Because part of what I see in the user interface is that as I move the mouse around, every once in a while, strange things happen, and I have to be able to see that. So if there's flickering on the screen, I might not see that flickering in a test case that says move the mouse precisely there and expect this answer. And the answer is right. But if you then drag the mouse just a little bit, things change dramatically, and that's wrong. So I still have to manually drive the program to see where the problems are. And when I see a problem, then I'll write a test case to reproduce that problem that I see, and then I'll put that into my suite, fix that problem, and then keep going on. So I can't depend solely on the tests. I have to run it by hand to make sure I capture all the things that are going wrong. And then I can write tests based on those. That's it. Are there any questions? I'll wait for the microphone.
So in your example, you had, as you were dragging what you were calling fixed size widgets onto the palette, you had two left and right size text boxes. Can you resize the fixed size? I mean, it's kind of a strange saying, but resizing fixed widgets. So if you put a button in the middle of that, from the drag handles, can you resize the widget?
Let me just try this. Right now, the drag handles don't work at all. But if I put a long label in and then just drag it a bit, then it works. So if I can intercept the changes to the label, then I can cause it to automatically refresh and re-layout, and then it would work like this.
Okay.
So right now, none of the drag handles are operational. And eventually I want to get those going and have those snap to fractions. But if you at least change the size of the fixed size widget, it does relay it up the right way.
So in this version where you don't have the nested widgets, what about cases like when you want to nest it, like a bunch of radio buttons within the box? How do you see that working in this kind of?
Okay, say that again. You want what?
Like a bunch of radio buttons moved together in a group box, so you can lock them in a group.
Yeah, let me try that. Group boxes are one kind of control that I'm still trying to work out right now how to handle. I can place radio buttons one on top of the other. Right now, group boxes are handled just like other